You know that feeling, that specific frustration? You ask an AI to write some code,
Yeah.
and technically, it works. It runs.
Oh, yeah. I know exactly what you're talking about.
But you look at it and you get this feeling in your gut that says, that is not my code.
It feels alien.
Exactly. It feels like a stranger wrote it. It ignored all your naming conventions, totally forgot about your testing
Oh,
rules.
using some library you guys deprecated like 3 years ago.
Yes. It's like you hired a freelancer, gave them zero onboarding, and just said, here, go work on our production branch.
Yeah, that's the classic generic bot problem right there. You're asking a model that was trained on, well, the entire internet.
The average of everything.
The average of all code ever written, yeah. And you're asking it to suddenly act like it's been on your specific team for 5 years. It's just a huge mismatch.
Right. And the advice you always hear is, oh, you just need to write better prompts. You need to be a prompt engineer. But the research we're diving into today says that's actually a trap. We're looking at something totally different, a concept called context engineering.
And this is a really significant shift. It's moving away from this idea that talking to an AI is like a conversation or an art form.
Right.
And it treats it as a rigid engineering discipline. The goal isn't to, persuade the bot to write good code. The goal is to architect an environment where writing bad code becomes statistically impossible for it.
Statistically impossible. That is a very bold claim. But the source material, it breaks this down into a specific methodology, a blueprint, really.
Yeah, a recipe.
A recipe with 3 specific ingredients and 1 golden rule. And I want to be super clear for everyone listening. This isn't just about coding faster.
No, speed is a byproduct. The real goal here is coherence.
It's about making a junior developer produce output that looks like it came from your lead architect, which, I mean, that sounds like magic.
It does.
But when you look at the mechanics, it's actually it's a lot of really heavy lifting on the front end.
That's the catch, isn't it? The promise is automation, but the price is preparation. You have to build the brain before you can actually use it.
So let's pay the price. Let's break down this recipe. The source starts with this premise that context isn't a vibe. It's a set of engineered documents. Ingredient number 1 is deep technical specifications.
This is the foundation. And we have to be really careful with that word context.
Okay.
Because most developers, when they hear context, they think it means pasting their current file into the chat window.
Right. Local context. Fix this bug in lines 10 through 20.
Exactly. Deep technical specifications are global context. This is about documenting the physics of your engineering world. And it starts with something surprisingly humble.
What's that?
The README file.
The README. The file everyone knows they should write, but it's usually just a title and maybe a broken link to a wiki somewhere.
Humans skip it. We all do.
Yeah.
But the AI needs it. The source argues for a README standard that's basically a complete instruction manual for the environment.
Okay, so what goes in it?
Think about it. If a new senior engineer joined your team today, what's the very first thing they'd ask?
How do I turn this thing on? Or where's the database?
Right. How do I seed the database with dummy data so I can actually run the app?
Do I start the back end first or the front end?
What port does the auth service listen on? All of that. If you don't write this down for the AI, it just hallucinates the setup. It assumes a generic one, which means the code it writes won't actually work on your machine.
So you're saying we have to teach the AI how to set up its own desk before it can even start working?
Precisely. And then you have to go a layer deeper into the architecture. This is a really interesting part of the source material. It talks about explicit architectural definitions.
Like what?
Like, is your team using hexagonal architecture? Are you doing domain-driven design, DDD?
Oh, I can see why that matters. If I just say make a user service, and I don't mention DDD, I'm probably just going to get a generic MVC controller.
Because that's the most common thing on the internet, exactly. And if your code base has this strict separation between the domain layer and the infrastructure layer, that generic code is it's useless. You have to rewrite it.
So the context has to explicitly say, we use hexagonal architecture.
Yeah.
Interfaces go here, adapters go there. Business logic never touches the database directly.
You got it.
Okay, but here's a practical question. Describing architecture in text can get really messy and long. It feels like explaining a painting over the phone.
It does. And that's where the mermaid trick comes in. This was one of my favorite takeaways from this whole deep dive.
Yeah, explain that for us, because when I think of diagrams, I think of a screenshot or a PNG file.
Which an LLM is terrible at reading. I mean, it can try to interpret the image, but it's fuzzy. It misses the details. Mermaid is a syntax that lets you write diagrams as code, as text.
Oh, interesting.
Yeah, you define relationships with brackets and arrows in plain text, and it renders as a chart. So because it's text, the LLM can parse the structure perfectly.
So it's a token-perfect representation of your data model.
Exactly. You're not just telling the AI users have many posts. You are giving it the entity relationship diagram in a format that's native to its brain.
That's so clever. And it also seems like a great bridge for the non-technical team members.
Huge. The source makes a big deal about this. If your business logic is mapped out in mermaid charts in your docs, a product manager can take that file, feed it to their own AI agent, and ask, what happens to user data when an account is deleted?
And they get an answer without bugging the lead dev who's in the middle of something.
Right. It turns your documentation into a queryable database of your business logic.
Okay, so we have the set up the RIA-DM and the structure with the mermaid diagrams. What's the third part of these deep specs?
Security and patterns. Security by design. This is where you stop hoping the AI writes secure code and you start mandating it.
So explicit rules.
Very explicit. We do not construct SQL queries with string concatenation.
Yeah.
We sanitize all inputs using the specific library.
It prevents the AI from being lazy because the default path for an LLM is often the path of least resistance, which is often insecure.
It is. And the same goes for design patterns. If you use the factory pattern, say it. If you strictly follow solid principles, write that down.
I have to play devil's advocate here, though. This sounds like an enormous amount of work. I mean, writing a textbook about our own code before we even write the code, who has time for that?
It is. It's a lot of work, no getting around that. But the source has this meta tactic that I think is brilliant.
Which is?
You don't write it all from scratch. You use the AI to bootstrap the context for you.
So you use the AI to write the rules that will restrict the AI.
Exactly. You act as the expert architect. You use something called few-shot prompting. You give the AI a template, maybe a perfect readme you found, and you say, look at my code base and generate this level of documentation for it.
You're front-loading the effort, but you're using leverage to do it.
And once it's done, it's done. I mean, it's a living document, sure, but the foundation is laid.
All right, so that's ingredient one. We have the statics, the maps, the rules, but code isn't static. It's a process. Which brings us to ingredient two, the workflow.
And this is where most people fail. They give the AI the what, the specs, but they totally forget the how. The software development lifecycle, the SDLC.
The source calls this the human process. Why does a machine need to understand a human process?
Because the order of operations completely changes the outcome. The best example the source gives is test-driven development, TDD.
Ugh, I love TDD in theory, but I am terrible at actually sticking to it.
We all are. But if you want the AI to do it, you have to be rigorous. If you just ask an AI, write a function that calculates a mortgage rate, what does it do?
Spits out the function.
Right, jump straight to the solution. But in TDD, that's illegal. The first step has to be writing a test that fails.
So you have to script the behavior for it. Step one, write the test. Step two, run it, watch it fail. Step three, write the code.
And step 4, verify it passes. And step 5, and this is the one AI always skips refactor, if you don't explicitly force that workflow, you just end up with code that works but has
zero test coverage.
Zero test coverage. And that breaks your team's standards.
So the workflow ingredient is basically forcing the AI to show its work.
It's enforcing the definition of done. A task isn't done when the code runs. It's done when the code is written, the documentation is updated, the unit tests are passed, and this is really cool, a QA report is generated.
A QA report.
Yes. The source suggests having the AI generate a little report at the end of every task. I ran 50 tests, 50 passed, coverage is 92%, no regressions detected.
Huh, it's like having a super compliant intern who fills out all the paperwork that I always skip.
That's exactly what it is. And to get that, you have to feed it this document that describes all of this. And this brings us to what, for me, was the most controversial part of the source material.
Oh, yes. The back-end standards document.
The 1,000-line text file.
A single massive text file with everything.
Everything.
My immediate reaction when I read that was just horror. 1,000-line monolithic file. That sounds like a maintenance nightmare.
I had the same reaction. It feels like a total anti-pattern. But hear me out. For a human, a 1,000-line document is unreadable. For an LLM,
It's nothing.
it's a snack. And because these context windows are getting so massive, 200K, a million tokens, you can afford to be that verbose. You can dump your Git strategy in there.
We squash merge, we don't rebase main.
Yes, or your naming conventions. Variables are camel case, database fields are snake case.
All the petty stuff that causes friction in code review.
All of it. You missed a semicolon. You didn't update the Swagger docs. If it's all in that context file, the AI catches it before a human ever sees it.
So if I'm getting this right, we've built a system. We have the specs, the map, and the workflow, the rules of the road. Now we actually have to drive the car. Ingredient 3, the task.
The task is the variable. It's the one thing that changes. Fix this mug, add this button.
And the theory here is, because those first 2 ingredients are so heavy and so controlling, the task prompt itself can be incredibly simple.
That's the whole prompt wizard fallacy. People think they need to write these complex paragraph-long prompts.
Oh, I do that all the time. Please act as a senior developer. Please don't forget security.
Please don't break the build.
Yeah.
With context engineering, you don't do that. Your prompt is just create the login endpoint.
Because the senior developer persona isn't in your prompt anymore. It's in the files.
It's hard-coded. The AI looks at the task, it looks at the 1,000-line standards file, the SDLC workflow, and it says, okay, to create a login endpoint, I must use TDD, I must use these security patterns, and I must output a QA report.
It restricts the search space. It can't go off the rails because the rails are electrified.
That's a vivid way to put it, but yes. Consistency is the golden rule here. Whether you ask for a feature, or I do, or a junior dev does, the output looks identical.
And this leads right into the final big idea from the source material, this idea of democratizing seniority. This is the payoff.
This is the ROI conversation. Why spend days writing docs? Because it fundamentally changes who can do the work.
The source uses that metaphor of giving the keys to the car.
Right. Think about a junior developer. Fresh out of boot camp, they're smart, they're energetic, but they're also dangerous. Dangerous to the code base. They don't know the history. They don't know why that weird architectural pattern exists. They might introduce a dependency that breaks everything. So we gatekeep.
We bubble wrap them. Don't touch the core services. Just work on this UI button.
Exactly. But if the AI is strictly enforcing the architecture and the security rules, the bubble wrap can come off.
Because the junior isn't writing the code from their own limited experience. They're operating the system that contains the senior's experience.
The AI acts as the guardrail. If the junior tries to do something that violates that 1,000-line standard, the AI just corrects it. Or it follows the standard instead. It allows a junior to ship production-ready code on day 1.
I want to push on this a bit, though. Is there a downside? I mean, if the AI is doing all the architectural thinking and the junior's just prompting, make feature X, do they actually learn? Or do they just become operators of a black box?
That is the critical risk. You could end up with what I call passenger developers, people who can ride in the car but have no idea how to fix the engine when it breaks.
Right. If the context is wrong, if the standards are broken, can the junior even spot it?
Probably not. And that's why this whole thing shifts the role of the senior. The senior isn't the code writer anymore. The senior is the context engineer.
They're the one maintaining that 1,000-line file.
They're the ones ensuring the mermaid diagrams are accurate. They move up a level of abstraction. They're programming the organization, not just the application.
It's a shift from individual productivity. How fast can I type to collective standards?
Right. If the senior updates that one standards file, everyone on the team instantly gets better. The junior's AI agent immediately starts using the new pattern.
That's a powerful multiplier. It solves that problem of, I sent an email about the new coding standard, but nobody read it.
You don't send an email, you update the context file. The system enforces it automatically.
But it all hinges on maintenance.
Okay.
Documentation drift is the enemy, right?
It's the enemy. If I change the database schema, but I forget to update the mermaid diagram in context folder,
Then the AI starts hallucinating. It writes code for a database that doesn't exist anymore.
Exactly. This methodology actually requires more discipline than the old way. It requires front-loading the work.
It's funny, for a while the vibe was no code. You know, AI will just do it, we won't need docs.
And now we're saying, actually, you need more documentation than ever before, and it has to be perfectly machine-readable.
The irony. Ambiguity is the enemy of automation. You have to externalize your brain into these text files.
Externalize your brain. That's a great way to put it. You're cloning your best architect and letting everyone on the team borrow that clone.
Okay, so to recap for everyone thinking about how to do this, we have the recipe. 1. Deep sex. The re-ADME, the architecture in Mermaid, the security rules.
Here, remember, use the AI to write the first draft of those specs.
Right. 2. The workflow. Defining the STLC, forcing TDD, requiring the QA report.
Don't let it skip the tests.
And 3, the task. Keeping the prompt simple because the context carries all the weight.
And the philosophy under all of it. Treat your context as code, version control it, review it, debug it.
It's a compelling vision. It moves us away from prompt engineering, which feels like guessing, to context engineering, which feels like building.
It's reliable. That's the key word, reliable.
I want to leave our listeners with a final thought here. We talked about how this empowers juniors, but there's a flip side. If this really works, if we can capture the essence of seniority in a set of text files, what happens to the definition of a senior developer?
That's the big question, isn't it?
Is seniority now just the ability to write good context? Or are we automating the senior right out of the loop?
I think the value just shifts. The code itself becomes a commodity. The standard becomes the asset. And the person who defines that standard, they own the value.
The architect becomes the king. The coder becomes the prompter.
The brave new world.
Something to chew on while you stare at that empty readme file on your project today? Maybe give it a little extra love. That might be the most important code you write all week.
Absolutely.
Thanks for diving deep with us on context engineering. We'll see you on the next one.